back to workshop number 2 of the 2 workshops of Unique Network. Today we will continue from where we left off in the last workshop. Max will at one point give you an overview of what we did and some additional info regarding the setup. But before we jump into that, let me just give you an overview of kind of what we want to cover in this workshop so it can meet your expectations. We'll be going into the metadata aspect of how do you set them and manipulate them in the UI. Also, we'll provide you with a simple UI to inspect that metadata. We'll touch upon mutability. We'll go into nesting. We'll talk about dual addressing from the EVM side and from the substrate side. And we'll just touch upon the subject of the EVM and the contracts and not go deep into them because that is a topic in itself. There is actually a workshop we did for a previous hackathon, which will be very useful. We will provide the links. And that one goes really deep into the details of how you do that. But before we do that, just one more kind of note regarding the overall way we approach development through the Unique SDK. So as you've probably figured out, Unique SDK is a TypeScript framework or a tool, a development tool, with which you can make calls to a RESTful API to affect certain contracts which then manipulate the blockchain. So in the most direct way, there is a separation which is very useful for the developer in the sense that you make the calls and things happen. It allows you to develop very rapidly, and you never worry about the contracts in the background being the latest version and so on. So that's the great benefit. But there is one aspect of it that is interesting, and that is, in a sense, the application making the calls is centralizing parts of the interactivity. And this is a very important point in which we have to touch upon with the separation of concerns. The contracts that the SDK calls up, they're rock solid contracts that do exactly what you want them to do. Putting a developer into a position to rewrite them over and over again and check them is pointless. Therefore, it should not be a concern of the developer to interact with or build protocol contracts. This is what the Unique SDK provides, an ability for you to call those functions which do things in a secure and guaranteed way. Now, when you separate these concerns and make an application that does something, the application itself is, of course, affecting the NFT. And you might say, well, I don't want it to be centralized in the application. That is not application should not be the one to do the affecting. I want this to be done by a contract. So it can be a centralized initiated event. And this is also possible to do, but not at the protocol level. You cannot modify the core protocol effects, such as the simple transaction of an NFT, because you would be overriding the security. Therefore, here we touch upon the separation of concerns. What it is that you want to be done through a contract is a very deliberate decision. Things that do not need to be done via a contract are really supplied by the Unique Network SDK, and this allows you to move very, very fast. However, I have opened up the door to the big question of how do you then extend the functionality of NFTs, and I hope you will glean the answer to this question, which is an open question actually, at the end of this lecture. Max, over to you. That was the rather large intro, larger than I intended. Go ahead.
Hey everyone, can you see my screen? Philip, can you confirm?
Nope. But oh, it just popped in.
Yeah, great. Okay,
Right.
let me make a very quick recap of what we've learned so far. So, on the previous workshop, we've learned how to set up your environment, and here is our documentation, docs.unique.network. Here is environment setup. Here you will find Docker Compose, just copy paste it, and you will get your local blockchain, which work fast, 2 seconds per block, a bunch of development accounts. You will also have SDK endpoints, both for SDK and indexer, and you will use these endpoints in your on the client side here during SDK initialization. And one more thing, I just added it. It's like very simple UI. We will look into it today. This UI can serve as a very simple explorer, so you can check how your collections or NFTs will be displayed in different user interfaces, such as marketplaces, wallets, and so on. So let's go to ID. We also learned how to initialize SDK. Again, we need only REST URL, and you can easily switch to production just by changing this URL to public one. We've learned how to set up account, and we can set this account as a default account for our SDK to sign these transactions. We've learned how to create the collections, and that collections are just containers for NFTs. They have some basic metadata such as name, description, symbol, and it also specify rules of how your NFTs will work in your application or in different on the protocol level. As far as you create collection, you can create NFTs, and it's also very easy to do. In this example, we create 2 NFTs, and we learned that NFT is just a bunch of properties mostly. And yeah, and we also learned 2 different concepts. First is properties, and properties just a core level key value pairs that can be set to arbitrary data. But we also learned that SDK creates very specific, very special property called token data, which is agreement. So it's not a protocol level property or something. So it's just an agreement. And in this token data property, we store something that called metadata. So, quick recap, metadata is everything that is important for your NFT appearance, everything that is responsible of how your NFT will be shown in different user interfaces, such as wallets, marketplaces, and everything that is responsible for your NFT rarity, such as
Ma-
attributes.
Max, can I jump in here with one comment? So, the token data and the properties of a token are two classes. And Max mentioned something very interesting. Collections can have properties, and you can imagine, you would ask, like, well, why? What's the purpose of having the properties of collection? And you can look at it this way: the properties that you set in the collections are actually inherited or carried over by all the tokens, are the common attributes for all the tokens in a collection. So it's a superset that ensures that all the tokens have some common attributes.
Yeah, okay. So again, we have metadata, which we stored in token data property, and some random properties we can specify. I don't know, whatever we want to. So, for example, today we will be prototyping. We begin prototyping very simple card game. This card game this will be sort of Hearthstone like game. We'll have some collection for that, and we want to store some data which is application specific. For example, we want to store some timestamps of last battle for some reason. I don't know why. So for that, we can choose properties. We don't want to expose this timestamp to. We don't want it to be shown on different different user interfaces. We just want to use it for our application. So for that, we just decided to set it into properties, and we specify this property on the collection level called timestamp of last battle. And we also set some basic metadata for our NFT. So let's just go and let's just look what is the metadata. So we specify image here. I just pre-uploaded a few images here. So this will be the image of our warrior, the name of NFT, description, and just a few attributes. So we can set more attributes. Probably we should set more traits, like I don't know what else, like I don't know, color and value, right, or something like that. I don't know. Maybe we want to set this attribute for our NFT. Okay, so now let's just see how our NFTs will be shown in our block explorer. So I'll run this script. Let's wait a few seconds. Okay, it's done. Let me update. We created our collection. Inside this collection, we created a few NFTs. The first one for our warrior, the second one for a sword. Let's check how the NFTs will be shown. So this is approximately how your NFT will be shown in marketplace, for example. So it will be name. Here will be some description you set, and some attributes. We set rarity and color for our NFT. So custom properties probably will be exclusively for your application, so will not be shown this timestamp code. Okay, and here, very interesting concept. Let's just discover this concept. It's called dynamic NFTs. So by default, okay, no, when we create properties for our NFT, we can specify permissions. So we can make any property mutable or immutable. For example, if you create some kind of art, you probably want to set your property as immutable. But for our game, we want to mutate some properties of our NFT. And we can specify who can mutate these properties. For example, here we said that both collection admin and token owner can mutate this property. This is probably incorrect. We don't want to allow our users to mutate this NFT property. So we'll set it to false. So this way, our timestamp of last battle will be mutated for our collection admins. And we, as a collection owner, we are admin as well, so we can mutate this property. But as I mentioned previously, token data and our attributes is also property. This means that actually this data we set here is actually it will be a property called token data, created by our SDK automatically. And by default, this token, so we don't need to specify this token data property like this. It will be created automatically by SDK. And by default, this token data property will be mutable, and it will be mutable for collection admin only. This is how our metadata will be defined on the core level. So again, we don't need to specify it like this because it will be created automatically. I will comment these lines. So because of that, because our metadata is mutable, we can actually mutate this metadata for our NFTs. And for example, if we want to create some mechanics where our warrior, after some number of battles, has, I don't know, become more like change image, for example, or do something else, we can mutate our NFT attributes, and let me show you how it will be done with SDK. So we can do it like this. We have SDK.token and update NFT method. Here we need to specify collection ID. We need to specify token ID. I can receive it from our collection token creation function. So it's token transaction. But because it's like sequential number, I know that my warrior will be token ID 1. Let me, for simplicity, I'll put this the 1. And we can set data. So we can mutate this metadata. Again, for example, for our example, I will set a new image for our warrior. And let's just see how it will be on UI. Let me run this script again. So because we create a new collection, it will be demonstrated here. Oh, okay. Here's our second collection, and you may see we have a little bit different golden warrior, not the same like this. So this way we can update our NFT with some events and so on, and this is how it's done. We can also, of course, mutate some attributes. For example, we can probably set, I don't know, number of bottles, and we can increment this property, right? For example, it has 0 by default, and we can set it like attributes and trade type number of, I forgot how it made, number of bottles, and we can set it to 1. Of course, we will programmatically automate it, but just let me just demonstrate how it will be done. So again, just wait for a few seconds. So now we created our collection number 3. Here's our warrior. It's not updated yet, so it has epic rarity and it has 0 battles. And now we update it. Done. So image changed, number of battles changed. Oops, we should also set rarity as well. So we removed this property, so we need to set it as well. But okay, that's it. So this is how you can mutate these attributes.
Max, if I can jump in. So here's an important kind of thing we have to say straight out to kind of disambiguate this big confusion about mutable NFTs. So as you've seen, in Unique Network, all NFTs can have mutable attributes, on-chain mutable attributes. That's a very important point. So it's not a reference to an off-chain data which is being mutated. This is on-chain mutation of data. By definition, then it would be proper to say, well, then why make the distinction of dynamic NFTs? I mean, all your NFTs are mutable. That is, all your NFTs are dynamic by nature. That's very true. This is the reason why we make a very kind of subtle distinction when we name some NFT as a dynamic NFT. We mean to say that there is a contract or a process which is attached to the existence of this NFT in some way that it modifies it. So we can talk about this idea later on with contracts, but generally, a dynamic NFT changes online via some kind of contract or a process in the background. And this is what we mean when we say dynamic NFT in unique network.
So a few more words about metadata. So what else can we set here? So a lot of stuff, but the most important ones are media. So for example, if you want to create not just images, but I don't know, music NFT, you can use this media property. It will be shown on most user interfaces. So here you can set whatever you want. So let's say audio one, and you can specify which type of this media. So for our example, it's audio, and of course to set some link, HTTP to IPFS and so on. And we can create as many properties as we want to. We can create 3 audios or some, I don't know, some PDF file, document, and so on. One more important thing is royalties. So if you want to have some royalties when your tokens will be traded, you can specify them here in this key. And you need to just specify which address will receive this this royalty and percentage. For example, 3%. So it's important to know that it won't be enforced on the protocol level. It's just it's just an agreement. So most marketplaces will respect this royalties field, and they will enforce this royalty payment. But while they should respect this property, it doesn't mean they have to. So they can ignore this royalties property. Okay, let me just ignore it. Okay, so now let me also remove this media. Now let's also check one more, learn one more concept. So which is bundles and nesting. So again, by default, on unique network, every NFT technically has 2 different IDs. So first one is token ID, which is a number just in sequential order, starting from 1, and second NFT will have ID 2, and so on. But also every NFT has this token address, which is, let me show it closer, which is Ethereum address. It's deterministic address. Doesn't mean that we really have some contract on this address, but using this address, we can send other NFTs or fungible tokens, and this way, this NFT will own different NFTs or different fungible tokens. For example, you can nest USDT into your NFT, or you can nest. In our example, we are going to nest this word inside this warrior NFT. So let me just demonstrate it, and then I'll explain how it works. So nesting, and this is how easy you can do it with SDK. We have this nest method. We just need to specify parent NFT, and for parent NFT we'll be using our warrior, and for nested NFT we'll be using our sword, which is NFT number 2. Let me run it again. I'll stop here Just wait a few seconds.
I mean, Max, it couldn't get simpler, right?
Yeah. So again, we created one more collection. Here we have water, and you may see that my account currently is owning this water, and this word is also owned by me. Well, technically by Alice, this account we use. And now we are going to nest one token into another. Well, okay, no, this transaction will fail. Actually, I forgot one important thing. Let me show you. It will fail. It failed. It fails because we need to specify. We need to set nesting on the collection level first. So by default, your NFTs are your collections do not support nesting. You need to specifically set these permission on the collection level. And here we have permissions property, and we can set nesting. We can set nesting for collection admin. We can also allow our users to nest NFTs inside our collection. And one more property is we also can restrict nesting for specific collections. So for example, we don't want to nest everything in our warrior NFT. We want to allow only these words to be nested. So we can set that only for this collection, nesting will be restricted. I don't want to show it, simply I'll remove it. So our nesting will be permissionless and it won't be restricted to any collection, to any specific collection. So let me run the script again. Okay, so collection number 5, and for our warrior owned by us, our sword is also owned by us. But as you may see, our warrior has this address, and which is Ethereum address, which is discovered. And after we nest this NFT, okay, let me update. And yeah, our sword now is owned by this address, which is a bunch of zeros 5, which actually means number of collection, and this one is number of tokens. So this is deterministic address of our warrior. Let's double check it. So yeah, this is our warrior's address. So now this NFT owns this sword. But
Max, got to jump in here and say just one thing to highlight the power of what you just displayed. So please keep in mind, the NFT actually acts as a wallet. It has an address. It is addressable, and you can send something to it. That means that it can receive a token. In receiving a token, it actually has the token that it was sent to it nested under it. This is why we say nesting in unique network is contractless, because there's no special nesting contract. It's just simple sending an NFT to an NFT and nothing more. At the protocol level, the magic happens. An NFT acts like a wallet, and we have the nesting effect.
Right. So yeah, this NFT owns this word by default. Because we own this NFT, we also kind of owner of this NFT. But for this, we have special property called special term, which called topmost owner. So, for example, if we request this NFT, SDK token get, and we will request this Sword NFT. Sword, let me call it Sword NFT. You will have this topmost owner. This topmost owner will be our Alice account, this one. And because of that, because we are topmost owner of this Sword NFT, we can unnest it or we can burn it. So we still own this NFT. We still can manage it. So, okay, this is
Can
how.
I jump in with just one more note here? So, in the process of creating an NFT that has other NFTs nested under it, we're introducing a new concept which we call in Unique Network a bundle. A bundle is actually the name of the topmost NFT that contains many nested NFTs under it. Max will explain why we look at it as a bundle. It has to do with what happens when you transfer the root, the container, the topmost NFT, what happens to the whole collection, and so on. It actually acts like a bag or a bundle.
Yes, right. So let me just demonstrate what you can do with NFT. Again, I'll show this Wood Universe collection, which was recently launched on Unique Network. So for this real NFT collection, we have some cabins, and inside these cabins, we have some stuff like TV or something. What else here? We have some chairs and all these NFTs, because we can mutate our attributes and we can change image of our NFTs. We can set new image for our NFT, for example. This is how we can create some different mechanics with together with nesting and mutability of NFT. Okay, this is like fantastic example of this nesting and mutability. Okay,
Oh,
we
Max.
yeah.
Max, again, I got to say, since you showed the cabin as well, so I just want to tickle your fancy with this idea. Imagine, since the television set can be an NFT object, you can have NFTs which are channels, that is live streams, and if you nest these NFTs which reference channels or certain videos, you can have a nested collection of channels. You can switch through the interface of, let's say, a television set or something like that. And this is the way the NFTs serve a function in structuring the data which is related to the object itself, which it is representing, right? So in this case, the television does not implement these channels, but I'm just using this as a way for you to understand what is the relationship between NFTs and why it makes sense to implement nesting in creating this kind of relationship between objects. That's all.
Okay. So, okay, this is how the most important mechanics work on unique network. But here, one important question may appear. It feels like not the real Web3, right? If you have some private key which is stored on the backend and side, and you invoke it every time your users do something on the front end. So it's like it's not a real Web3. It's like Web2 approach, and it's kind of true. It can be true for your application. So, but here's very important thing that everything you can do with SDK. So in this way, we have our privilege accounts, our admins. We can later we can migrate to contracts. So with contracts, we can set we can set these contracts as collection admins and specify rules how these contracts can mutate NFT. So instead of calling these methods directly, we can create a special contract that will do exactly the same. And thanks to precompiles, we can manage our NFTs, we can change them, we can transfer them using contracts and EVM side. So, and we also can invoke contracts using substrate accounts. So these two worlds, they are both interactable from both sides.
And Max, can I jump in with just one important point here? So add this to what Max just said. The contracts that you're building, they, on the Solidity side, they can invoke the core protocol functions of unique network, the ones that actually the SDK calls as well. This means that you can separate these core protocol calls like transfer, mutate, and whatever into a contract and have it as a separate, decentralized process, which you can then invoke as a contract.
So let me show you a few links. Here is the first one. No, it's a unique template. It's called unique contracts. We have npm library. This package gives you some methods that you can call from Solidity. And what's more important, you will find here in this unique contracts repo, you will find some recipes, how to create some kind of wallet using Ethereum wallet or some POAP-like applications or NFT minter. And what's more important, maybe for this hackathon, we have this example of a game where you have some creatures, you create some creatures, and this contract can mutate NFTs in completely Web3 way. So it will be decentralized, permissionless, it will be unbreakable, and so on. So all the important things will be implemented here, and it covered with comments, so you can easily understand how it works. And we have this demo which uses this contract for this game. Again, it's like very simple and silly game where you have some sort of creatures, and these creatures can fight against the other creatures. And in this game, your creature has some experience and has some generation, which can be evolved with battles, and no private keys will be stored on any backend, so it's completely Web3 way. So if you want to implement this Web3 way, just learn this workshop and you will know how to do this. But my suggestion would be, if you start building on unique network, you probably need to start with unique SDK, make things a little bit centralized Web2 way with private keys, with admin private keys, because later you always can migrate all this logic into contracts. So prototyping first, make your game engaging, or if you do not the game but some application, make it useful, and after that you can migrate all this centralized logic that you implemented with SDK into contracts. Basically, that's it. So Filip, should we cover something else?
Let me just give an overall kind of view at what you just said here, that kind of might map the concepts that we're talking about. So to go back to what we're actually doing when we're using the SDK, we are invoking functions that are actually part of these libraries that we call palettes, right? So unique network has a set of palettes that secure at the protocol level that certain operations are guaranteed and secure, right? So these function calls that are in these pallets, they are the ones that do the work of everything that is happening on unique network. So the SDK, the unique SDK, is actually a convenient way to utilize TypeScript function encapsulated methods and functions calls. When I say methods, it means when I say a method, what I actually mean is it encapsulates a certain intent. For example, um, set up metadata, create a collection, mint a token, which might be a complex set of operations which engage the functions of the pallets in a certain specific way. So the SDK makes it easy for you to manipulate at a higher level the what you want to have as the results which are affecting the blockchain. So you use this SDK to make it easier on you. But the problem with this is the way the SDK works is it actually makes a call to an API which executes this operation on the blockchain, which means, as Max mentioned, that the initiator of the operation is centralized. In this case, it is centralized in the application that is making the call. This is why we mentioned at the start, you always think of the separation of concerns and ask yourself, well, what do I want to separate from this centralized way of manifesting the application? Well, what you do then is very simple. You see, the contracts that are created in the EVM using the Solidity code, they can make calls to these pallet functions directly, which means they essentially access the same functions in the pallets as the SDK does. However, they do it at a much lower level. There is a direct mapping of all the functions that are in the pallets in the EVM environment, which means you can create contracts which can produce the same effects that the SDK can, but they can be separated from the application, and that means they can be decentralized in effect. So when we were talking about the idea of separation of concerns, it is up to the developer to figure out which aspects of his application need to be decentralized and for which it is absolutely an overkill to create contracts, right? So this balance is the fine line and the fine dance that one makes when they're creating their application. And this is why Max mentioned a very important idea. He said you can migrate some of your behaviors or actions to a contract at a later stage, which means what? The SDK provides for you a way to really, really rapidly develop everything that you want to see happening. It cuts down from months of development to just a week of development. I'm not talking out of my hat. I'm talking from the experience of the developers we've had contact with and who've told us that this is exactly the effects and how it's changed their expectations in how much time it takes to develop something on the unique network. So the point being, using the SDK, you rapidly develop. At some point, you say to yourself, well, I'd actually like to, let's say, separate the minting of additional tokens out of the application. I want to make it a contract, which is initiated, as Max said, in the classical way, the Ethereum side way, a decentralized operation independent of the application itself. And you actually can do exactly that. And then progress with the application. Again, having a clear idea of what are your separation of concerns in terms of what your application should do. I hope this makes sense for you, and I hope it will help you kind of structure your approach to developing.
Thank you, Filip.
Well,
do we have any questions?
If there are any questions in the comments chat, we can answer them. Let's see if there are any. Hey, sir. Okay, I have no way to answer one of the questions that is set forth there. I don't know. There are actually no questions that are relevant in the comments, so we can skip that. And as for the previous workshop, we will be providing the links to the relevant code references that we mentioned in this workshop, and also some helpful links to documentation that touches upon this. And it will be published, of course, in the Hackathon Builder Party common channel. So that concludes the Unique Network workshop 2 workshop set of workshops that demonstrates how to develop and create on the Unique Network. We hope this was helpful for anyone that chooses to jump into a project. All the best to you. We wish you all the luck, and we wish you a wonderful experience. We will be supporting you during the hackathon, so reach out to the through the channels and the support channels, especially the Unique Network developer support on the Telegram, and we will be in a position to answer any of your specific questions. Thank you very much.
Thank you very much.